Physics paper, question 1. Which of the following cannot be regarded as an essential characteristic of a unit of measurement? A. Inaccessibility. B. Indestructibility. C. Invariability. D. Reproducibility. So, inaccessibility is not an essential characteristic of a unit of measurement. The other three are. So, option A is the correct answer. Question 2. The unit of absolute permittivity is. Farad per meter is the unit of absolute permittivity. That is option B is your correct answer. Question 3. A man wants to reach point B on the opposite bank of a river flowing at a speed as shown in the figure. What minimum speed relative to water should the man have so that he can reach point B? In which direction should he swim? Now, let V be the speed of boatman in still water. Resultant of V and U, that is basically, would be V, this will be the direction of U. So the resultant of V and U would be along this direction, will be along the AB component. Components of that is basically would be VB bar. Now components of VB bar along X and Y. So this VB bar, its component along X and Y would be Vx, Vy. So Vx would be U minus V sine theta. Further, since the angle is given as 45 degree, tan 45 will be Vy by Vx. So I can have 1 is equals to V cos theta divided by U minus V sine theta. So I can say V is equals to U divided by sine theta plus cos theta, which would be equal to U divided by root 2 sine theta plus 45. V would be minimum at when basically theta plus 45 would be equal to 90. That is basically for sine 90, this would be 1. So that is when V would be minimum. That is basically when the sine factor will be 1. So theta plus 45 when it is 90, sine of 90 is basically 1. So your V value would be minimum at that point. So from here I can obtain theta is equals to 45 degree. So your V minimum would be equal to U divided by root 2. So correct answer is option B. Question 4. A body crosses the topmost point of a vertical circle with critical speed. Its centripetal acceleration when the string is horizontal will be. The topmost part crosses with critical speed. So velocity at top is basically root of 3 rg. Acceleration will be v square by r, which will be 3 rg divided by r, which will be equal to 3g. So the correct answer here will be option B, 3g. Question 5. A car is moving with a speed of 30 meters per second on a circular path of radius 500 meter. Its speed is increasing at the rate of 2 meters per second square. What is the acceleration of the car? Now net acceleration is what we are supposed to find. We are given tangential acceleration, which is 2 meters per second square. We have to find centripetal acceleration, which can be written as (900) divided by 500. So your AC value is known to us, that is basically AC would be V square, that is 30 square divided by R, so 900 by 500. So your resultant acceleration will be AT square plus AC square. Substitute the values, you will get the answer as 2.7 meters per second square. So correct answer is option B. Question 6. A block of mass capital M is pulled along a horizontal frictionless surface by a rope of mass small m. Force P is applied at one end of the rope. The force which the rope exerts on the block is. Now acceleration is equal to P divided by capital M plus small m. Force on the block will be mass of block multiplied by the acceleration. So which basically means mass of block in capital M, acceleration is P divided by M plus M. So correct answer here is option D, that is Pm divided by M plus M. Question 7. A box is lying on an inclined plane. What is the coefficient of static friction if the box starts sliding at an angle of inclination of 60 degree? Now angle of inclination given as 60 degree, mu is equal to tan theta. Basically theta is angle of inclination, that is tan 60, which will be 1.732. The correct answer is option B. Question 8. A body of mass 5 kg is placed at the origin and can move only on the x-axis. The force of 10 Newton is acting on it in a direction making an angle of 60 degree with the x-axis and displaces it along the x-axis by 4 meters. The work done by the force is. So work done is nothing but Fs cos theta. So force is 10, displacement is 4, angle with the x-axis is 60 degree. So you get the answer as 20 joules. So which is option D. Question 9. The moment of inertia of a thin uniform rod of mass capital M and length L about an axis passing through its midpoint and perpendicular to its length. Its moment of inertia about an axis passing through one of its end and perpendicular to its length is. So I0 is the moment of inertia of the thin rod about an axis passing through the midpoint, to its midpoint and perpendicular, that is to the center. So here your I would be equal to I through the center plus M L square by 4. That is basically a length is L by 2, that is why ML square by 4. Since we are using the parallel axis theorem, which states that I would be equal to I from center of mass plus mh square. So here your h is nothing but L by 2, which becomes L square by 4. Your ICM would be your I0, so this will become basically I0 plus ml square by 4. That is correct answer is option C. Question 10. A circular disc of mass 0.41 kg and radius 10 meter rolls without slipping with a velocity of 2 meters per second. The total kinetic energy of the disc is. So kinetic energy would be equal to half mv square 1 plus k square divided small k square divided by r square. This is your ke. So half multiplied by 0.41 multiplied by 2 multiplied by 2 square multiplied by 3 by 2, which would be equal to 1.23 joules. So option B would be your correct answer. Question 11. A uniform annular disc as given in the figure of mass capital M and outer radius 4r and inner radius 3r. The work required to take a unit mass from point P on its axis, that is this, to infinity is. Now, work done would be equal to delta U, which is U final minus U initial, which basically is U at infinity minus U at the initial point P, which would be equal to now minus of UP, which will be equal to minus of MVP, which equals minus VP as M is equals to small m is equals to 1. Now potential at point P will be obtained by integration as I'll be showing you. Let dm, small dm, be the mass of small rings as something like this. Dm is mass of a small portion of the ring. Now dm would be equal to m divided by pi 4r the whole square minus pi 3r the whole square multiplied by 2 pi r dr. dVp would be equal to minus g dm divided by root of 16 r square plus small r square. Now your dm is all of this, which is basically 2m r dr divided by 7 capital R square. So you'll substitute the value of dm. So this you'll get basically on integrating, you'll get 2gm with a negative sign 7r square integral 3r to 4r r divided by 16 capital R square plus small r square dr. On solving all of this, you will obtain the work done would be 2gm by 7r 4 root 2 minus 5. So your correct answer would be option A. So here your correct answer would be option A. Question 12. The twisting couple per unit twist for a solid cylinder of radius 3 cm is 0.1 Newton meter. The twisting couple per unit twist for a hollow cylinder of same material with outer and inner radius 5 cm and 4 cm respectively will be. Twisting couple per unit twist for solid cylinder and for hollow cylinder, that is the hollow cylinder, is 4 eta r raised to 4 divided by 2l. So for the hollow cylinder, C2 would be equal to C1 R2 raised to 4 minus R1 raised to 4 divided by R raised to 4. Substitute all of these values, you will get 36.9 divided by 81, which is nothing but 0.455 Newton meter. So that is option B is your correct answer. Question 13. A bird is sitting in a large closed cage which is placed on a spring balance. It records a weight of 5 Newton. The bird of mass 0.5 kg flies upward in the cage with an acceleration of 2 meters per second square. The spring balance will now record a weight of. The effective weight will be weight of bird plus reaction force due to the acceleration of the bird, which is basically 5 plus ma, which will be 5 plus 0.5 into 2, which is basically 6 Newton. So your correct answer is 6 Newton. Question 14. A water film is formed between two parallel wires of 10 cm length. The distance of 0.5 cm between the wires is increased by 1 mm. Which will be the work done? Surface tension is given as 72. Now, work done would be equal to 2 multiplied by tension into change in area. So 2 multiplied by 72 multiplied by 0.6, that is the final distance between the two is wires is 0.6 centimeter minus 0.5 into 10, which will be 144 ergs. That is option B. Question 15. According to the experiment of Ingenhouse, the relation between the thermal conductivity of a metal rod is K and the length of the rod whenever the wax melts is. So I have to find relation between thermal conductivity and length. So here, according to Ingenhouse, the relation is given by K by L square is equals to constant. That is basically K is directly proportional to L square. That is option C is your correct answer. Question 16. A cyclic process for 1 mole of an ideal gas is shown in the figure in the volume versus temperature diagram. The work done in AB, BC and CA respectively are. Now, AB is an isochoric process because volume remains constant. So, work done at AB will be equal to P delta V, which is 0. work done for BC, which is isothermal process as temperature remains constant, will be RT2 ln V2 by V1, and work done at CA, which is isobaric process, that is temperature and volume are changing and pressure is constant. So work done at CA would be equal to P delta V, which will be equal to R delta T, which is basically RT1 minus T2. So your correct answer here is option C. Question 17. Adiabatic modulus of elasticity of a gas is 2.1 multiplied by 10 raised to 5 Newton per meter square. What will be its isothermal modulus of elasticity? Cp by Cv equals 1.4. So gamma, which is Cp by Cv, is given as 1.4. So Es by Et would be equal to Cp by Cv, which is basically gamma, will be 2.1 multiplied by 10 raised to 5 divided by Et equals to 1.4. So you will get the value of Et from here as 1.5 multiplied by 10 raised to 5. So option C is your correct answer. Question 18. An air bubble of volume 1 centimeter cube rises from the bottom of a lake 40 meter deep at a temperature of 12 degrees Celsius. The volume of the bubble when it reaches the surface, which is at a temperature of 35 degrees Celsius, will be P1 V1 T1 equals to P2 V2 by T2. So I'll have P plus H rho G, that is because the bubble is at some depth, multiply the volume 1 divided by 273 plus 12 equals to P V2 273 plus 35. So from here I will obtain value of V2 as 5.4 centimeter cube, which is option A. Question 19. The displacement of two particles executing SHM are represented using equations y1 equals to sine 10t plus theta and y2 equals 3 cos 10t. The phase difference between the velocity of this particle is, now v1 dy1 by dt equals 2 multiplied by 10 cos 10t plus theta. V2 will be dy2 by dt, which is minus 3 multiplied by 10 sin 10t, which can be written as 30 cos 10t plus pi by 2. So the phase difference would be 10t plus theta minus 10t plus pi by 2. So phase difference 10t plus theta minus 10t plus pi by 2, which is basically theta minus pi by 2. So your correct answer here is option D. Question 20. 5 identical springs are used in the following 3 configurations. The time period of vertical oscillations in configurations 1, 2 and 3 will be. Time period is inversely proportional to root k. So basically T1 is to T2 is to T3 would be 1 by root k is to 1 by root of k by 2. As for this combination, that is the second combination, the resultant value will be k in series, so k by 2, and for the parallel combination here it will be 2k, that is k plus k, to 1 divided by root of 2k. Simplifying this will give you 1 is to root 2 is to 1 by root 2. So the correct answer here would be option A. Question 21. In a resonance tube, using a tuning fork of frequency 325 Hz, 2 successive resonance lengths are observed at 25.4 cm and 77.4 cm respectively. The velocity of sound in air is, now V equals to 2n L2 minus L1, which will be 2 multiplied by 325, 77.4 minus 25.4. Solving this will give you an answer of 338 meters per second. So option A would be your correct answer. Question 22. If n drops each of capacitance C coalesce to form a single big drop, then the ratio of energy stored in the big drop to that in the small drop will be. Here, the ratio of energy in the big drop to that of the small drop will actually be n raised to 5 by 3 is to 1. Question 23. A spherical condenser has inner and outer spheres of radii A and B respectively. The space between the two is filled with air. The difference between the capacities of two condensers formed when outer sphere is earthed and when inner sphere is earthed will be. Now, capacity when outer sphere is earthed will be C1, which is 4 pi epsilon 0 AB divided by B minus A. When inner sphere is earthed, C2 will be 4 pi epsilon 0 B plus 4 pi epsilon 0 AB divided by B minus A, which will be basically 4 pi epsilon 0 B square divided by B minus A. So difference, that is C2 minus C1, on solving you will obtain as 4 pi epsilon 0 B. So your correct answer here is option C. Question 24. 27 small drops each having charge Q and radius R coalesce to form big drop. How many times charge and capacitance will become? Let capital R and small r be the radii of the bigger and smaller drop. Charge remains conserved. Hence charge on bigger drop will be equal to 27 multiplied by the charge on the smaller drop. So charge on the bigger drop, which is Q dash, will be 27 times charge on the smaller drop. Now before and after coalescing, volume remains the same. So 4 by 3 pi capital R cube will be 27 into 4 by 3 pi small r cube. So basically you'll have capital R equals 3 times small r. So capacitance of big drop C dash will be 4 pi epsilon 0 capital R, which is equal to 4 pi epsilon 0 3 times small r. So which basically is 3 multiplied by 4 pi epsilon 0 small r, which is the capacitance of original small drop, one small drop, so 3C. So C dash will be equal to 3C. So here originally there were 27 small drops, so your charge, final charge is 27 times the original charge, and your final capacitance is 3 times the original capacitance. So your correct answer will be option B. Question 25. A battery of EMF E and internal resistance small r is connected to an external resistance capital R. The condition for maximum power transfer is. Now we know that current I is equals to E by R plus small r. Now, power delivered to the resistance capital R will be P equals I square capital R, which will be equal to E square capital R divided by R plus R the whole square. We want the power to be maximum, so dP by dr should be equal to 0. So we will differentiate this. So on differentiating this, we would obtain R plus capital R the whole square equals to 2 times R small r plus capital R. On solving this, we will get capital R equals to small r. So basically you can also remember this condition as whenever for a battery of EMF E and internal resistance small r is connected to an external resistance capital R, maximum power transfer is possible when capital R is equal to small r. So actually this option is wrong. It should be capital R equals small r. That is our option D. Question 26. The potential difference between point A and B is, so we have to find the potential difference between these 2 points. Now 8 by 6 is 4 by 3 and the other side is already 4 by 3. So actually this is a balanced Wheatstone network, because of which potential between points A and B will be 0. So your correct answer is option D. Question 27. At neutral temperature, the thermoelectric power dE by dt has the value. So at neutral temperature, dE by dt is 0. So your correct answer is option A, 0. Question 28. Two thin long parallel wires separated by a distance small d carrying a current I ampere in the same direction. They will, option A, attract each other with force of mu 0 I square by 2 pi d, repel each other with a force of mu 0 I square by 2 pi d, attract each other with a force of mu 0 I square by 2 pi d square, or repel each other with a force of mu 0 I square by 2 pi d square. So here, the force per unit length between the two wire F by L will be equal to mu 0 by 4 pi multiplied by 2I square divided by d. So which basically means mu 0 I square divided by 2 pi d. And the force will be a attractive force because the current is moving in the same direction for both. So your correct answer here would be option A. Question 29. Direction of magnetic field at equatorial point is anti-parallel to capital M, that is magnetic moment. That is option D is your correct answer. Now, question 30. The correct measure of magnetic hardness of a material is, coercivity is the correct measure. So whenever you want to measure hardness of a material, that is magnetic hardness of a material, coercivity is the measure that is used, which basically means the field strength required to be applied in opposite direction to reduce the residual magnetism of the specimen to 0. So C will be your correct answer here. Question 31. A conducting square loop of side L and resistance capital R moves in its plane with uniform velocity V, perpendicular to one of its sides. That is, this is the velocity. A magnetic induction B, constant in time and space, pointing perpendicular and into the plane of the loop, exists everywhere with the part of the loop outside the field, as shown in the figure. The induced EMF in this case is, magnetic flux linked with the loop is changing. So induced EMF E will be BLV. So your correct answer here is basically option C. Question 32. An inductive circuit contains a resistance of 10 ohm and an inductance of 2 Henry. In an AC, voltage of 120 volt and frequency of 60 Hz is applied to this circuit. The current in this circuit would be nearly. Now, Z would be equal to root of R square plus XL square, which would be root of 10 square plus XL being 2 pi N, that is frequency, 2 pi 60 to L, that is 2, the whole square. So in solving this, we will obtain 753.7 ohm. I would be equal to 120 divided by 753.7, that is 120 being the voltage. We will get the answer as 0.159 amperes. So correct answer is, in this case, option B, that is 0.16 amperes approximately. Question 33. In a series LCR circuit, resistance R is 10 ohm and impedance Z is 10 ohm. The phase difference between the current and the voltage is. Now, R is 10 ohm, Z is also 10 ohm. So basically XL minus XC is equals to 0. That is when Z is equals to R. So when XL minus XC is 0, tan phi, which is given as XL minus XC divided by R, will be 0 by R. So tan phi is equal to 0. So phi will also be equal to 0. So correct answer is option A. Question 34. Refractive index and the permeability of a medium are respectively 1.5 and 5 multiplied by 10 raised to minus 7 Henry per meter. The relative permittivity of the medium is nearly, so we have to find the relative permittivity. And refractive index is given as 1.5, mu 0 is given as 5 multiplied by 10 raised to minus 7. Refractive index mu is equal to root mu r epsilon r. So epsilon r would be equal to n square divided by mu r. So I would obtain from here, I will get rho is equal to n square mu 0 by mu. So basically this is obtained, that is your epsilon r is n square mu 0 by mu, because mu r is mu by mu 0. So substituting all of these values, you will get epsilon r is equals to 6. Value of mu 0 is 4 pi multiplied by 10 raised to minus 7. N is given to you, that is the refractive index, and mu r is also given to you. So you'll get epsilon r equals to 6. That is option D would be your correct answer here. Question 35. The length of the tube of a microscope is 10 centimeters. The focal length of the objective and eye lengths are 0.5 and 1 centimeter. The magnifying power of the microscope is about. Magnifying power is LD divided by F0 FE. That is focal length of objective and focal length of eyepiece. Length is 10, D is 25, 0.5, 1. So answer will be 500. So option D is your correct answer. Question 36. A man of length h requires a mirror to see his own complete image of length at least equal to, your correct answer would be h by 2. Question 37. Which of the following has zero average value in a plane electromagnetic wave? Magnetic field and electric field both have zero average value. So option A is your correct answer. Question 38. If F1, F2 and F3 are the frequencies of the corresponding K alpha, K beta and L alpha X-rays of an element, then now for K alpha emission, transition is from L shell to K shell. For K beta, it is from M shell to K shell. So for K alpha, it is L to K shell. For K beta, it is from M to K shell. And for L alpha, it is from M shell to L shell. So I will get E M minus K equals to, this will be E L minus K, this will be E M minus L, E L. So basically I would get E M minus E K equal to E M minus E L plus E L minus E K. Okay. Which basically is obtained, basically M to K would be nothing but M to L and then L to K. So that is how this equation is obtained. So we will get HF2 equals to HF3 plus HF1. So basically I'll get F2 is equals to F3 plus F1. So that is option C would be your correct answer. Question 39. While doing his experiment, Millikan one day observed the following charges on a single drop. 6.563 multiplied by 10 raised to minus 19 coulomb. 8.204 multiplied by 10 raised to minus 19 coulomb. 11.5 multiplied by 10 raised to minus 19 coulomb. 13.13 multiplied by 10 raised to minus 19 coulomb. 16.48 multiplied by 10 raised to minus 19 coulomb, and 18.09 multiplied by 10 raised to minus 19 coulomb. From this data, the value of the elementary charge E was found to be. Now, any charge in the universe is given by Q is equals to NE. So E is nothing but Q by N. So here, when you see Q1, Q2, Q3, Q4, Q5 and Q6, there will be a common term among all of this, all of these, that is basically a common multiple. That common multiple would be 1.6 multiplied by 10 raised to minus 19 coulomb. That is basically, you don't even need to solve this question because you know already the value of elementary charge is 1. Now only thing is the exact value of an elementary charge is 1.641 multiplied by 10 raised to minus 19 coulomb. Remember this value, that will be your direct answer. Question 14. The angular momentum L of an electron moving in a stable orbit around the nucleus is. Now for an electron to remain orbiting around the nucleus, the angular momentum should be a multiple of h by 2 pi. That is, L should be nh by 2 pi, some integral multiple of n. So the correct answer here would be option C, integral multiple of h by 2 pi. Question 41. Hydrogen plus deuterium gives you something called X plus an electron plus an energy, basically a positron. This basically, when we look at atomic numbers, 1 1 1, that is total is 3 here, and the 1 is on the right hand side, there's 1 already taken by the positron, so what will remain over here is 2. On the atomic mass side, 2 plus 1, that is 4. So this is nothing but a helium nucleus or alpha particle. That is, option C is your correct answer. Question 42. Nuclear forces are. Nuclear forces basically charge independent, and it also acts between two neutrons. So it's a short range attractive force and charge independent. So option A is the correct answer here. Now question 43. In the circuit given below, A, B, C are the inputs and Y is the output. So we have to find what is the output. So A, B will become here A plus B the whole bar. C comes here. So in this AND gate we get Y would be equal to A plus B the whole bar dot C. Now this basically we would have to make a truth table kind of thing for this question. On solving it, you would obtain that the answer is that the output is low for all inputs. So any kind of input is given, that is whatever the value of ABC, value of Y is always low, that is 0. Question 44. A telephone link operating at a central frequency of 10 GHz is established. If 1% of this available, then how many telephone channels can be simultaneously given, with each telephone covering a bandwidth of 5 kHz? 1% of 10 GHz will be 10 multiplied by 10 raised to 9 into 1 by 100, which is 10 raised to 8 Hz. Number of channels will be equal to 10 raised to 8 divided by the bandwidth of each, which is 5 multiplied by 10 raised to 3. So it is 2 multiplied by 10 raised to 4. That's the answer. Option A is the correct answer. Question 45.